Hello everyone, welcome to Dr. Ravi's Academy. In this particular video lecture, we will be understanding the concept of free body diagram. So, the definition of free body diagram, and by means of some simple examples, we will be understanding the supports as well as the loading. So, let us look at the definition of the free body diagram. It is the sketch of the isolated body showing all the active and reactive forces. So you are isolating the given body. Sometimes you may have a connected system, and the body under consideration you are isolating from the surroundings, and on that you are representing active as well as reactive forces that act on it, and you are removing with appropriate supports. That means you are removing the supporting elements, and you are incorporating appropriately the reactive forces upon the body which is under consideration. So this is the definition of free body diagram, and of course it's very important topic of your engineering mechanics. And in order to understand that, let us by means of some simple schematic diagrams, let us understand how to represent the support reactions. So let us take types of supports. What are the various supports you have and how to replace it appropriately? So I am considering, let us consider a flexible support. Let us assume that you have a ball, supported weight of ball is W, and it is supported by means of a flexible member. And let us draw the free body diagram of this particular system. Let us draw the isolated view of the diagram of the body under consideration, that is the ball. And upwards, it is a flexible member. The tensile force is developed, and which is always away from the body, and weight is passing through the center of gravity of the body, which is downwards. So this is the free body diagram of this particular flexible support. And let us consider a smooth surface. A block is resting on a smooth surface. So this particular surface is said to be smooth surface. The moment you say having a weight of W, let us assume that. And to draw the free body diagram of this particular block, let us draw the block diagram of the sketch of the diagram of the body, that is block, and weight is acting vertically downwards through the centroid or center of gravity of the body, and perpendicular to the contact surface normal force is acting. This is what is exactly perpendicular to the contact surface. This is the free body diagram of this particular block when you say that it is smooth. And if you consider smooth surface instead of smooth, if it is a rough surface, I'm treating that it is the block is resting on a rough surface. So this I am calling it as rough surface. And whenever you will come across with rough surface, you are going to replace it with let us say the weight is W acting vertically downwards, and it is normal reaction and frictional force. So always a rough surface you are going to be replaced with the two forces. One is the frictional force, which is opposite to the direction of the impending motion, and a normal force. So observe carefully the difference between smooth and rough. And after all, you understood that how to represent this, and by means of two simple beams, simply supported beam as well as a cantilever beam, how to represent, let us understand. I am considering a simply supported beam. Means one end you have a pin connection, and A is, I am calling it as a pin or hinge support, and the other end is you have a roller support. I am representing three rollers. You may have three rollers or simply maybe one roller. So always this draw the diagram of the beam as it is, and always the pin or hinge is replaced with one horizontal and one vertical support reaction. I am calling it as reaction at A horizontal reaction at A vertical. A hinge support always replaced with the two support reactions, and a roller support is replaced with a single support, let me call it as RB, and which is perpendicular to the contact surface. So this is what is exactly simply supported beam. A hinge is replaced with two forces, a roller support is replaced with a single force. And let us understand a cantilever beam, a fixed end beam. So let us assume that you have a fixed end. This is what is known as a fixed end beam, or it is cantilever beam. So this is cantilever beam. CB stands for cantilever beam. So always a cantilever end is replaced with, you have one horizontal force, vertical force, and a bending moment also. So this is what exactly you are going to replace the fixed end, and this sometimes the fixed end is also known as a clamped end. Fixed or clamped end, you are going to replace with two forces and one moment, and these are the generally you'll come across with the various types of supports. And after this, let us understand what are the various loads you'll come across. Let me discuss under this types of loads. As you know that you have three types of loads. One is point, or which is also known as concentrated load. Concentrated load, and this usually acting at a point. Let us consider a beam, and it is represented maybe P, load P, and another load Q, acting at let us say point B and at C, and the other end is D. So this is what exactly known as a point load, right? And you have a second type of load. It is called UDL, uniformly distributed load. It is a uniformly distributed load, which is also known as a rectangular load, which is also known as rectangular load. So this is something like a beam. It is represented with a rectangle of height small w, length L. So this is the load, and usually you will be calculating the area of the diagram. That is, area is let us say area A is equals to, this is nothing but your point load, equivalent point load is equals to length multiplied by W, and which is exactly acting at the midpoint. It is acting at a distance L by 2. So this P is acting at a distance L by 2 from the left hand or right hand. So you can replace UDL, that is rectangular load, by means of a point load by calculating the area of the rectangle. And lastly, a triangular load. A beam, assume that it is uniformly varying. It is called UVL. It's called UVL, and which is also known as a triangular loading. It is a triangular loading. So this is also area of the diagram, and let us see that this height is W, and it is linearly increasing from left to right. Area of the diagram is nothing but it is load half into length is L and height is W. So WL by 2 will be acting exactly at the centroid, and that is at a distance L by 3 from the base and 2L by 3 from the apex. So these are the usually the various types of loads you will come across in the solving the problems, and these are the various types of supports you will come across in solving the or in drawing the free body diagram and solving the problems. Thank you for watching this video.